Morning guys, today we are back with another problem, and today's problem is making and constructing a binary tree from a linked list. Okay, so if you see, given a linked list of a linked list representation of complete binary tree is to construct binary tree and bring the level order reversal of the binary tree. So we have to basically construct from linked list a binary tree. So we can write it over here. We are constructing from linked list a binary tree. Okay, a binary tree. So this is a very good problem statement because it will help you clear your fundamentals of how a queue data structure works, okay, and how a linked list works and how a binary tree actually works, okay. So if we carefully see one thing, that they have said in the question. So let us first analyze the question. The complete binary tree is represented by a linked list, okay. So we can write it over here. A complete binary tree is represented by a linked list, okay. A complete binary tree is represented by a linked list. Next, what they're saying is, in a way, if the root is node is stored at the position I, if a node is stored in position, its left, right, and children are stored at position 2 into I plus 2, respectively. And h is the height of the tree, and space is used implicitly for the recursion stack. And this space, height of the tree, and the space is used implicitly of the recursion stack. So we can imagine, say for example, we have a linked list, okay. So sample linked list, okay. We have a sample linked list. So in the sample linked list, what I can basically write, say for example, I have some values, say 15, 17, 18, 19, and 20. So my root element is equals to, so if I put this linked list and the, say for example, I put the index of this linked list, what I can say, write over here the index of the linked list as 0, 1, 2, 3, 4. Now, according to the formula, what formula they have given, that the I position is if the root node is stored at the position I. So root equals to I, okay, root equals to I. So what next is there? And the right and the left and the right are 2 into I plus 1, 2 into I plus 2. So left equals to 2 into I plus 1. So if I see in my first traversal, I is equals to 0. So 2 into 0 plus 1 is 1. So my left element is 1. So this 17 is having the index value of 1. So this is my left element. Now my right element has another formula. So right equals to 2 into I plus 2. So in this case, I can see 0 plus 2 equals to 2. So this 2 is pointing towards this. So I can write this is as right. So I can clearly understand one thing. How my data structure is going to look like. So if I see a queue representation of this data structure, what I can see is this is my middle element, okay, and this is my say 17 is the left. So 17 will be pointing over here and 18 will be pointing over here, and I have to print this representation. So in order to understand this representation, I can further show it in the form of a binary tree, because we have to generate a binary tree from a linked list. So the first is 15, and then it is pointing to 17, and then it is pointing to 18. Okay. So this is how the representation of this particular problem works. Okay. This is how we are going to represent this binary tree. So next, what we see, h is the height of the tree, and the space is implicitly used for the recursion of it. Now let us analyze the question. Let us analyze this question. So for example, they have given n equals to 5. So you can see the maximum elements, maximum height of the level order binary tree is 5. Okay. Now k equals to 1, 2, 3, 4, and 5. What is this k? K is nothing but a queue data structure which is storing these values. Okay, k is storing these values 1, 2, 3, and 4, and 5. Now in what order I am going to follow? So if you see, say for example, if I follow the formula, then this is 0, 1, 2, 3, and 4. So if I see my left element equals to 2 into I plus 1, which is how much? Which is nothing but 1. So my first data structure will show 1, okay, and then over here left equals to 2. So over here 2 is coming, okay. Now right equals to 2 into I plus 2 equals to how much? 2. So over here we will have 3. Similarly, again for left I am going to calculate, okay. Now my left 2 into 2 is how much? My left will become 2 into 1. So 1 is 2 plus 1, 3. So if I see 3 is this position, okay, 3 is this position, which is holding a value 4. So over here, the next left element is going to be 4. And similarly, if I see for the fifth element, the fifth element would be on the right side of this 2, because whenever we are considering this statement, this is of the right side. So how we are going to see this, that this is a level order transformation or level order traversal? So the basic thing is, in level order traversal, at all the stages, the elements has to be filled. If you see, at all the stages, the elements are filled, the elements are filled, elements are filled. Okay, and this is the structure of the level order traversal. Okay, so in this case, you could understand. Now we are going to understand the code and how this code is working. So before that, before solving this code, what I have noticed is they have already made the driver function, which has how to declare a node class, how to declare a tree class, tree node, and all those things. So you can see a node constructor will be present, a tree will be present, and all those constructors are present in default. What we have to do is basically we have to make a binary tree into a linked list. This is our objective, making a binary tree from linked list. Okay, so making a binary tree from linked list. So the objective is making a binary tree from linked list. So first we have defined a function tree convert, which has a data type as tree because it is returning a tree. Okay, we are taking the head and the node. Okay, so if you see a data structure of a queue of linked list, what it contains: data, okay, next and previous, data next and previous. So once I have data next and previous, how I can write this data next and previous as? I can write it in this, according to this question, this is data, this is right, and this is left. Okay, now next what I have, I am declaring, I am checking whether my head equals to null. So my head, which is pointing at the first root of the first root of the binary tree. So if this value is equals to null, then I'm going to return null, because it has to have some values. I can't just keep it null, right? So in this case, if it is null value, I'm going to return null. Then what we are using is a queue tree. So what queue tree basically is, queue is a data structure. In the queue, we are going to store the elements of the tree class. So in the tree class, we are passing the data type as tree, because now you will see from where is this tree coming. We have already declared this tree. Okay, so now queue, we have initialized the name of the data structure as queue variable. It can be XYZ anything. We are defining it as a new linked list. The tree root equals to new tree head.data. So head.data is nothing but pointing to the first element. Okay, now we are adding queue.add root. So you can write enqueue. In queue, a lot of data structures have properties, like in arrays, you are adding an element. In queue, in stack, so stack.pop means remove. So in case of queue.add means you are adding the root into the queue. Okay, now what I can see is we are taking a current node as head.next. Now we are going to traverse this root until this root node, current node, not becomes null. Okay, now we are taking a parent equals to queue.poll. So what is the function of queue.poll? Queue.poll is nothing but to take the front node from the queue. Queue.poll is nothing but to take the front node from the queue. So if I have a data structure, I'm going to take the first element. So I'm going to use queue.poll. Okay, like stack.pop, we have used stack.pop, stack.top for stack data structures. So now you will tell me, Anand, what is the use of this queue data structure? How is queue helpful? So in case of a queue data structure, it follows first in first out algorithm. First in first out algorithm. What is FIFO algorithm? FIFO algorithm is nothing but, say for example, you are standing in a queue in a toll plaza and your cars are just coming and going. So the element which comes first leaves first. The element which comes for execution first is get executed first. Okay, it's just like first in first out service. Okay, similarly what we are doing is we are taking the front node over here. Now we are creating the left child from the new next node in the linked list if present. So we are checking initializing the left and right as null. So initially if I'm taking left and right equals to 0 or null. Okay, left, right equals to null and 0. Now since this value, every time in linked list we have to follow the strategy that we have to check we have to traverse until the element becomes null. If it becomes null, this is not going to work. So you can see the left child equals to new tree current.data. So current.data is nothing but current.data is storing the current object, current data or present in the current linked list. Okay, now in the queue we are adding the left child, because I've already told you while explaining that we are using the formula I into 2 plus 1 by adding the left child at the first. Okay, now current equals to current.next. Current.next what basically does is it basically points to the next frame, next data type, and it makes the link. Okay, and it just acts as a loop. Create the current right child from the next node if linked list if present. So we are doing right child equals to similarly, and we are doing this and this. Okay. Now you can see we have done the exact same amount of code, exact same lines of code we have written, just it becomes right child and this becomes left child. Okay, nothing different is away. Now finally what we are doing, we are attaching the left and right child to the parent node. So in the parent node, we are first attaching parent left equals to left child and parent right equals to right child, and we are returning the root. We are returning the root. So this is a very simple code. It's not a very difficult code. You don't have to be confused or something like that. It might look bigger. It might look bigger, but linked list is actually very easy if you know that, oh, this is my left and this is my right and this is a parent. So I have to just attach this. For attaching this, I have to write a couple of lines of code. We have to use the q.add over here and all those things. Get the front node from the queue. Why we are taking q.poll? Q.poll we are using because suppose this is our parent, right? So parent is always on the top and children are below. Children are below. So in order to take the top, how will you take? We are just going to use the poll function. Okay, we are going to use the poll function. So that was about today's code, and I hope you like the explanation. You can just simply see this code. This code works and it has passed all test cases. Okay, all test cases. Okay. We are looking forward to see you in our next video. Thank you.